Today we're going to continue talking about set theory. In particular, we're going to talk about subsets, proper subsets, and counting subsets, as well as counting proper subsets. Let's begin with an example. I could ask you if the following is true or false. Is the set consisting of 2 an element of the set consisting of 1, 2, and 3? This is a false statement because 2 is an element of the set 1, 2, 3, but the set consisting of 2 is not. A subset of a set is a collection of objects from that set. Later on, we will give another definition. So let's look at an example. If we take the set A to consist of the elements 1, 2, 3, and 4, and if we wanted to take a subcollection or a subset from A, we could look at the set consisting of 1 and 4. We could also take a set consisting of 1, 2, and 3, and we could also take a set consisting of just 3. It turns out that there will be 16 distinct subsets from A, but we'll discuss that later. These are just 3 examples. We need to remember that a subset is a set, and so we need to denote it as a set. Therefore, we need to have the curly brackets. We also have another way to denote a subset. So if B is a subset of A, we can use this symbol that looks like a C with a bar underneath of it to denote a subset. Let's look at an example. Here's a set A consisting of the elements 1, 2, and the set 3, 4. These are all elements. Since it has 3 elements, namely the numbers 1, 2, and an element which happens to be a set, the cardinality of A is 3. We can now ask the following questions. Is the set consisting of 1, 2 a subset of A? Is the set consisting of 3, 4 a subset of A? Or is the set consisting of 3, 4 an element of A? It turns out that the first problem is true, because if we look at the subset consisting of 1 and 2, well, we also see 1 and 2 in the set A, so therefore the set 1, 2 is a subset or a subcollection. The next one happens to be false. So why is the set 3, 4 not a subset of A? Well, it turns out that the set 3, 4 is an element of A. Now let's talk about cardinality. A set with cardinality n will have 2 to the n subsets. If we look at the set with 2 elements, namely 1 and 2, we have a cardinality of 2. So therefore we would expect to have 2 to the 2, or in other words 4 subsets. And we see those 4 subsets listed above as the set consisting of 1, the set consisting of 2, the set consisting of 1, 2, and also the set consisting of nothing. That's the empty set. Here's our next definition of a subset. B is a subset of A if every element of B is an element of A. So for instance, we have that 1 is a subset of 1, 2 because every element of the set on the left is also an element on the right. 2, or the set consisting of 2, is a subset of the set 1, 2 because every element on the set on the left is also in the set on the right. We have that B, or if you will, the set 1, 2, is a subset of itself, which might seem a little bit strange, but we'll talk about that in a minute, because every element on the set on the left is also on the right. Now we come to this empty set. The empty set is always a subset of any set, and that's because, by definition, every element on the left, well, if we look at the empty set, it has no elements. Well, therefore, every element in that set is also an element on the right. All right. Here's another question, true or false? The set consisting of the elements 3, 4, and 1 is a subset of the set consisting of 1, 2, 3, and the set 4. This is false because the set on the left has 2 elements. The set on the left has the elements which happens to be a set and 1 number, while the set on the right has 4 elements, 3 of which are numbers and one of which is also a set. Let's look at another example. I could ask you, how many subsets does the set consisting of 1, 2, 3, and the set 4 have? Well, we look at the set and we see that there are 4 distinct elements. So by using the formula on a few slides ago, we have that there should be 2 to the 4, or 16 subsets. All right, let's go back and visit this idea that a set can be a subset of itself. Because every element on the left is also in the set on the right, any set is a subset of itself. Now, when we want to talk about subsets, right, the word subset kind of implies that something is smaller. And we actually come up with a new definition, which happens to be proper subset. So a proper subset of a set denoted B with the CA. So now notice that that almost looks like the subset symbol, except we don't have that bar underneath. So a proper subset is a set that is not, or a subset that is not the set itself. All right, let's look at some examples. Here we have the set consisting of 1, 2, and 3. We have listed below all of the subsets. By the way, A has cardinality 3, so we would expect there to be 2 to the 3 subsets. And if you count them, sure enough, we have 8 subsets. Okay, but I could ask you, what are the proper subsets? So a proper subset, again, is just a subset that isn't the whole set. So we take all the subsets and we throw out the one that's the whole thing. And when we count those, you see that we have 7. Now that makes sense, because almost all subsets are proper subsets. There's just one that isn't. All right, so we need to get some terminology down. If we look at this and we have the set consisting of 1 and 2, this is certainly a subset, but it's also a proper subset. So both of the symbols with the C with a bar and the C work. But it's not the case that these symbols are interchangeable. For instance, we have the set consisting of 1, 2, 3 is a subset of the set consisting of 1, 2, 3, but it's not a proper subset by default. So since all subsets are proper subsets except 1, it turns out that the number of proper subsets of A is 2 to the n minus 1, where n is the cardinality of A. All right, that finishes the lecture for today. We'll talk later.